I am going to work some problems from your worksheets in your Apex lesson, just so you can see some concrete worked out examples. This is for Algebra 1, Apex Section 2. We're working with Vertex and completing the square examples. Again, it does take a bit more practice than what I'm showing. I'll put some more YouTube videos from other teachers linked into your Hapara as well. Here we go. Let's look at a couple problems here. All right. So in your work, you are told, and I'm looking at 11.2.2, you're told to complete the square and to leave your answer in the form something squared equals something. There we go. So the goal is something squared equals something. And number 3, you are given 3x squared minus 6x equals 21. Now, this is kind of in standard form. It's not perfect, but that's okay. We can still work with it. The thing that is bothering me right off the bat is this 3. It's always a bit annoying when there's some number in front of your x squared piece. So the way we're going to get rid of that is quite easy. I can see that each of these numbers is divisible by 3. I'm just going to divide each piece by 3. And this isn't quite into completing the square yet. This is just getting set up so that our work is nice and easy. If we can make it look how we want it, we can complete the square just like we did in previous examples. So when I divide everything by 3, I'm left with x squared minus 2x equals 7. That looks much nicer. I like this problem more. Now, to complete the square, we want this to be a perfect square trinomial. Let's just make it look that way. I need to put some number here that makes it easily factorable into a nice perfect square piece. As a reminder, we're going to use our b value divided by 2 squared. That will allow us to create the nice perfect piece we want. So my b value is negative 2. So if I take negative 2 divided by 2, I get negative 1. Negative 1 multiplied by itself becomes positive 1. Be careful with these negatives. It's still inside parentheses. So negative 1 squared is positive 1. Now these two problems aren't the same. This is the problem I was given, but this is the problem I'm solving. So I need to make up for this little lie I'm telling. Because I wanted to have this nice perfect form, I lied and I said, well, I'm just going to change this problem so it has a plus 1. The way we make up for that is either subtracting 1 out here, or we could say I added 1 to this side, I can do the same thing to the other side. Whatever you do to one side of the equation, you must do to the other. There we go. So let's just rewrite this nice and neat. X squared minus 2x plus 1 equals 8. Now I'm back to my original problem. And I have this nice, perfect trinomial. If it helps, let me insert a step here, because I don't want to make it look like magic. I'm going to insert a step. What we have been doing is asking what number times itself, what two numbers multiply to 1 and add up to -2. This is just right back to that factoring practice. What two numbers multiply to 1 and add to -2? -1 and -1. Because I have the same thing multiplied by itself, I can just shorthand that. I have this piece times itself. There's the square. That's the point of all this kind of gibberish here. We're making it so we have this perfect matching set of pieces to get us to vertex form. Okay, this is it for number 3. Let's look at one more problem. Okay, I'm gonna look at, first getting my paper in the right spot. Look at number 5. Okay, for number 5, you are told to solve for x. Given 2x squared minus 24x equals -20. Alright, I'm going to start off just like the other problem. Just going to get rid of that 2. That's kind of annoying. I see that each of these pieces are even, so it's really simple just to go ahead and take a 2. So I'm left with x squared minus 12x equals -10. Much easier to work with. And we are going to use the same process, complete the square, to make this side have a nice, even squared piece. I'm going to take -12, divide by 2, square it. Right? -12 divided by 2, -6, squared becomes +36. So -6 squared becomes +36. So I'm just going to add in 36. Whatever I do to one side, I must do to the other side. This is called completing the square. So over here, I'll just rewrite this nicely first. -10 and 36 combine to +26. There we go. Now, what two numbers multiply to 36 and add to -12? -6. -6 times -6 gives me 36. And when I add these two together, I'm going to get that -12 piece. Now here's the payoff. Because I have a piece multiplied by itself, I can just write that. Piece squared. Here we are. And our initial problem was to solve for x. So we're taking this one step further than the last example. We are going to get x by itself. To get x by itself, I need to get rid of that square by doing a square root on both sides. Whenever you introduce the square root, remember there's the positive and negative version. One more step to get x by itself is to add 6 to both sides, which leaves me with x equals a positive 6 plus or minus square root of 26. There it is. This is both our solutions in one nice, neat package.